In this video, we're going to take a look at right triangle trigonometry and how to solve for missing angles. This falls under our learning target, I can solve right triangle. In order to calculate some missing angles, we're going to have to deal with some inverse functions. In this class, we've been dealing with sine, cosine, and tangent. Okay, these are functions that perform some sort of operation. If I were to type in the sine of 30 degrees into my calculator, a decimal is going to pop out. To kind of undo these things, I'm going to be using the sine inverse, the cosine inverse, and the tangent inverse. Okay, these look like the sine minus 1 buttons on your calculator. Usually you get to them by hitting second, sine, and then those inverse functions pop up. So in this first sample problem, I have the sine of theta equals 1/2. If I want to figure out what theta is, I need to get rid of sine. And to kind of undo sine, I'm going to take the sine inverse of both sides. So sine and sine inverse, that's going to undo each other, and I'm left with theta is equal to the sine inverse of 1/2. So I'm going to go ahead and type in sine inverse of 1/2, and I'm left with theta is 30 degrees. In this next problem, I see the cosine of theta is equal to 4/7. If I want to figure out the measure of theta, my missing angle measurement, I'm going to have to get rid of cosine on both sides, or get rid of cosine by taking the cosine inverse of both sides. Cosine inverse and cosine undo each other, so I'm just left with theta is equal to the cosine inverse of 4/7. If I type this into my calculator, the cosine inverse of 5/7 to 2 decimal places is 55.15 degrees. Now let's apply this idea to solve for a missing angle measurement in a right triangle. My first step is going to be to label my opposite, adjacent, and hypotenuse. My hypotenuse side is always my longest across from my 90-degree angle. The side across from theta, that's my opposite, or 5. And then the other side is my adjacent. I notice that I know my hypotenuse, and I know my opposite. So if I look at my SOHCAHTOA, the only function that deals with O and H is sine. So I'm going to set this up as the sine inverse, the sine of theta is equal to my opposite over hypotenuse. I'm looking for theta, so I have sine theta equals 5/10. In order to get theta all by itself, I'm going to take the sine inverse of both sides. Sine and sine inverse undo each other, so I'm left with the sine inverse of 5/10. If I type that into my calculator, I end up with theta is 30 degrees. Looking at this next problem, I'm trying to find the measure of angle A. So I know that theta is going to hang out at angle A. And in comparison with theta, I'm going to label my opposite, adjacent, hypotenuse. Across from 90 degrees, my longest side, that's my hypotenuse. Across from theta, that's my opposite, 8 centimeters, and the other guy hanging out is my adjacent. I notice that I have information about my opposite side and my adjacent side. So if I think SOHCAHTOA, the only trig function that deals with O and A is TOA, tangent. Okay, so I have the tangent of theta is equal to the opposite over adjacent. So the tangent of theta is equal to 8/12. In order to get theta all by itself, I need to take the tangent inverse of both sides. Tangent inverse and tangent undo each other, so I'm left with theta is equal to the tangent inverse of 8/12. And if I type that into my calculator, I have approximately 33.69 degrees. Okay, and let's try this one more time. We're trying to find the measure of angle X, so I'm going to put theta at angle X. I'm going to label my hypotenuse, my opposite, and my adjacent. I notice that I know information about my hypotenuse and my adjacent, so if I take a look at my SOHCAHTOA trig ratios, I notice that the only ratio with both A and H is my cosine. So I set it up as the cosine of theta equals my adjacent over hypotenuse. So the cosine of theta is equal to 15/24. I want to get theta all by itself, so I'm going to get rid of cosine by taking the cosine inverse of both sides. Cosine inverse and cosine undo each other, so we're left with theta is equal to the cosine inverse of 15 over 24. And if I type that into my calculator, I have approximately 51.32 degrees.